Secondly, we need to calculate the order up to level once we know the fixed period, which is 4 weeks. And this is the average demand during those 4 weeks, the fixed period, plus 2 weeks of our lead time, and K times the standard deviation during those 2 plus 4 weeks. And then we need to set the very same value for K. So as to the average demand, as I said, is the average demand during 6 weeks, this 4 plus this 2, which is 6 times the average demand during a single week, which is 250. So that first term of R is 1500. Secondly, we need to calculate the standard deviation during those 6 weeks, and that is the square root of 6 times the variance of our demand during 1 week, which is 6 times the square of 150, and that eventually is 364. So since we are using the same cycle service level, we still need to have K equal to 1.5. So we have this value, which is 1500, we have K, which is 1.5, and we have the standard deviation, which is 364. With all this, we can now this is the summary of we had in our previous slide. Okay, so now we can decide that our safety stock, which is this here, which is what we add to the demand during P plus LT, is 552, which is larger than the remember the safety stock we used to have in the previous policy. And the order up to level is that 1500 plus this safety stock, which is 2051. So in this case, a fixed period policy consists in placing an order every 4 weeks, and when we do so, we place an order so that our inventory level rises all the way up to 2051 printers, and with that we expect a service level of 93% as the one we had in the reorder point with which we started this exercise.